Hi Chemistry. Today we're going to come back to everybody's favorite subject, and that is conversion factors. Except this time we're not going to be using metric conversion factors like we did in the beginning. We're going to be using a new unit called the mole. So the mole is the amount of a substance, and that calculation is a calculated number. It's based on carbon and how many atomic mass units there are in one carbon. So don't get too tied up in that, but you do need to know that it's a counting unit. It is sort of a unit that has been manufactured and manipulated for our purposes in chemistry. It's similar to saying a dozen eggs. There's nothing, we know that there's a dozen, and dozen stands for 12 eggs. You generally don't go into the grocery store and say, I need 24 eggs. You say, I need 2 dozen eggs. Same thing with a gross. A gross of pencils is going to be 144 pencils. And we know that if you want more than one gross, you're going to end up with, you're going to multiply that 144 number by however many gross you have. So it's a conversion factor. It allows you to go between two things. And so 1 mole of carbon is equal to 12.0 grams of carbon. And this 12.01 grams is the number found on the periodic table. So we call that the molar mass. The molar mass, every substance has a unique molar mass. It's based on the periodic table, and it is the sum of all the elements in the formula. So if we're only talking about one element, it's just the one element's mass. If we're talking about a formula like carbon dioxide or water, then we're taking the number of carbons, finding their mass, adding them to the number of oxygens, and finding their mass as well. So we're going to have some more practice with that later, but that's the definition of mole mass. It's a counting unit. Okay, along with the mole is another unit, or another measurement called Avogadro's number. Avogadro's number is the number of particles in 1 mole of a substance. So we're taking the idea of a mole and we're figuring out how many particles, how many atoms, or how many molecules there are in 1 mole of that substance. So Avogadro's number has already been calculated. It's found on your reference table on the first page, so you don't need to memorize it. 6.02 times 10 to the 23rd particles is equal to 1 mole of any substance. So for example, aluminum, 1 mole of aluminum is equal to 6.02 times 10 to the 23rd atoms of aluminum. 1 mole of carbon dioxide is equal to 6.02 times 10 to the 23rd molecules of carbon dioxide. And so that's a standard number. 1 mole is always equal to 6.02 times 10 to the 23rd. Okay, so how do we use these? The way we use these is with a conversion process. It's very similar to what you already did in the beginning of the year. All you're doing is changing the factors that you're using. So we can go from mass to moles to particles. We can go back from particles, moles to mass, and we use basically 2 conversion factors, either flipping them up or down. So if we're going from mass to mole, we use 1 mole is equal to the molar mass. If we're going from mole to mass, we use the molar mass is equal to 1 mole. If we're going from moles to particles, we use Avogadro's number over 1 mole. If we're going from particles to mole, we use 1 mole over Avogadro's number. And this setup is the same. So whichever way your arrow is pointing, you're going to use the appropriate conversion factor for that particular step. Hopefully you won't have to memorize this, but you'll use units to help you remember what to put next and where to go next. But it is a good idea to write on your paper mass, mole, particles, and the arrows to help you just get in the practice of going from one thing to the next. So let's do some practice. Okay, so typically these are word problems. I know you're super excited because who doesn't love a word problem, right? Yes. And in chemistry, who could get more excited than that? So I wrote mass, mole, particles on the top so we could kind of keep track of where we're going. So our first example, example number 1. How many moles are in 11.9 grams of aluminum? So we're starting at we're starting with our known here, 11.9 grams. That's mass. and we're going to moles. That's our unknown. So we're going to set up a t-chart right here. We're going to put our known quantity there, and over here we're going to put our unknown, where we're going. So this is where we're starting, this is where we're going. And we're going to use the molar mass to get there. So we put the molar mass of aluminum, 26.98 grams of aluminum, is equal to 1 mole of aluminum. And then we can cancel grams, we can cancel aluminum, and we're left with moles of aluminum. We come over here and we see that we want moles of aluminum, so we check that off, and then we solve. So we take 11.9 and we divide by 26.98, and you come up with the answer of 0.441 moles of aluminum. And you have to have 3 significant figures because your starting number has 3, and that is the smallest number of significant figures that you have. So our answer is 0.441 moles of aluminum. So, example number 2. How many moles are in 1.2 times 10 to the 24 atoms of copper? So our known is atoms of copper, right here with particles, because particles can be either atoms or molecules. And our unknown is moles. So we're going to set up our t-chart with our known. And then over here, we're going to put where we're going, or our unknown, moles of copper. So we have 1.2 times 10 to the 24 atoms of copper. We're going to use Avogadro's number as our conversion factor, so we put that on the bottom because we want atoms of copper to cancel. And we put 1 mole of copper on the top because that's where we're going. So we're going to cross atoms and copper out because they cancel, and we're left with moles of copper, which is what we want. And then we solve 1.2 times 10 to the 24th divided by 6.02 times 10 to the 23rd, and we come up with 1.9 moles of copper. Okay, so that's a 2-step process, here to here or here to here, and vice versa. And so let's look at a problem that's a little bit more complicated with 2 steps. So we can go from particles to mass or mass to particles, and each set of arrows is a conversion factor. So you have to remember that there can be 1-step problems, just like we finished, or 2-step problems like we're going to do next. So example number 3 is, how much mass does 11.23 times 10 to the 23rd atoms of carbon have? So let's identify our known and our unknown. This is our known, 11.23 times 10 to the 23rd atoms, and our unknown is mass. How much mass do we want? So we set up our t-chart, 2 sections. So we write our known, 11.23 times 10 to the 23rd atoms of carbon. Over here we write our unknown, grams of carbon. Then we first want to get rid of atoms, so we have to use Avogadro's number. 6.02 times 10 to the 23rd atoms of carbon. We're putting that on the bottom so that atoms can cancel, and 1 mole of carbon goes on the top. So now we're at moles of carbon, but we need to be at grams of carbon, so we're not finished. So then we use the molar mass. We put moles of carbon on the bottom so that moles will cancel here and here. And then we put the molar mass of carbon, 12.01 grams of carbon on top. And we cancel out our units. We're left with grams of carbon, and we want grams of carbon, so that's good. So then you take your calculator. You put in 11.23 times 10 to the 23rd times 12.01 and divide that number by 6.02 times 10 to the 23rd atoms of carbon, and you get 22.4 grams of carbon as your final answer. So things to remember at this point. That was a lot. It was pretty fast. Hang in there. Go back and rewatch it if you need to. But things to remember as you do that. You need to write all your units. Say I wrote atoms, moles, grams, moles, grams. Write it down. If you don't write it down, you're going to get lost. You're not going to be able to see what you need to cancel and where you need to go to the next step. So write down all your units. Write out the elements. You don't have to write the whole word. Write the symbol. C, 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 C. It seems a little tedious for this particular problem. However, the next step is something much longer, and you're going to have to, again, know where you started and where you're going. So you need to learn, get into good practice, good habits, and write down your elements. Third thing to remember is go ahead and cancel out your units. Draw a line through the things that are the same so you can get rid of them and see that they don't count anymore. Because what converting is going from one unit to the next. If you don't mark that out, you can't see your progress. And then, over here I wrote, don't cross them out unless they are the same. So if you write atoms here and you write grams here, you can't cross that out. Those don't cancel. And since they don't cancel, that would be an incorrect step. So make sure that you are writing down all your things, and when you're crossing them out, they are actually the same words or symbols. And then number 4, what's your calculator input? So a lot of times students will solve this correctly, or they'll set it up correctly, and then they'll go and they'll put it in their calculator and come up with an answer, and they'll write it down, and they're done. However, if you are not careful with the way you tell your calculator to solve the problem, you will wind up with the wrong answer and you will lose points. So, watch your calculator. Your calculator does the mathematical calculation that you tell it to do. It does not have a brain. You have to use your brain and go back through and check to make sure that the calculator number makes sense. So don't rely on the calculator solely to solve your problem. Okay, so let's work out one together that has a little bit more blank space. Okay, so our problem, how many atoms does 48.2 grams of fluorine have? So we are starting at atoms and going to, we're starting at mass and going to atoms. So first identify the known and the unknown. So right here we have the known, and how many atoms is our unknown. Okay, so go ahead and write those letters over them to help you. So we're going to then set up the T-chart. So 48.2 grams of F2. Now I wrote F2 there. Why did I do that? I did that because fluorine does not like to be by itself. Fluorine likes to hang out with its buddy, fluorine, in a diatomic molecule. So we always have to remember those diatomics when we're working these problems. So I went ahead and I wrote F2 so I wouldn't forget. And then over here, we're going to write down what we want to get to. We want to go to atoms of F2. Okay, so we've set up our T-chart. Now we need to start plunking in our conversion factors. And the conversion factor that we want to do first is molar mass. So we want to get rid of grams of F2, so we're going to go ahead and write grams of F2 here. And our next step is going to be moles, so we're going to write moles of F2 here. It's always going to be 1 mole of F2. And we're going to use the molar mass. So the molar mass of fluorine all by itself is 18.99, but we can't use 18.99 because we have 2 of them. So we're going to take 2 and multiply it by 18.99, and that gives us 37.98 grams of F2. Okay, so I'm going to go ahead and cross out my unit so I can do a little intermediate check to see if I'm where I need to be. So my grams are the same, I'm going to cancel that. My F2 is the same, I'm going to cancel that. I'm at moles of F2, but I need to be at atoms of F2, so I'm not done yet. So I have to keep going. So I'm here, and I need to get to here. So I need another conversion factor. That conversion factor is Avogadro's number. So Avogadro's number, we want to go to atoms, which is what Avogadro's number is in. So I'm going to go ahead and put atoms of F2 here. And I want to get rid of moles, so I'm going to put moles on the bottom, moles of F2. It's always going to be 1 mole of F2 is equal to 6.02 times 10 to the 23rd atoms of F2. So I know, I can go plug those in, moles cancel, F2 cancels, and I'm left with atoms, which I want, and F2, which I want. So I have solved my problem. I have set it up. I haven't quite solved it yet, but I've set up my problem. And now I can solve. So I take 48.2, plug it into my calculator, multiply it, because remember that these horizontal lines mean, these vertical lines mean multiply. So 48.2 times 6.022. Then I'm going to divide that whole entire number by 37.98, because that's the molar mass. And when I solve that on my calculator, when I hit enter, I'm going to come up with 7.64 times 10 to the 23rd atoms of F2. And that is my answer. Now I'm going to ask myself, does that make sense? So 7.64 times 10 to the 23rd. I had a pretty big number here, and so I was multiplying, so I should still have a pretty big number here. And these are pretty close together, so my number should be kind of close to 6. So yeah, my number makes sense. If I had just had 7.64 as my answer, that would not have made sense, because I would have had this giant Avogadro's number. Okay, so that would have been a clue that my answer might have needed some work. So we're going to do a lot more practice with these molar conversions and these particle conversions in class. So if you don't understand, then watch the video again and know that we will have some practice time in class. Thanks, chemistry.